34. Let's take a look at question number 1. We have a light spring of natural length A and the modulus of elasticity 20 mg is placed so that it stands vertically on the horizontal plane. The lower end of the spring is fixed to the plane. A particle of mass m is attached to the upper end of the spring. The particle is then pushed vertically downward until the length of the spring is 3/5a. The system is then released from rest. Then we want to find the maximum extensions of the spring. So what you can do over here is that we draw a diagram. So there's a spring over here. Okay, so you have a particle attached on it. And this particle has been pressed. Okay, so from here, you press until here. Originally, this is the A. Then press until you have a 3/5a. Then after that, you release. It will go to the, it will reach until here. Okay. So this is the situations. Okay. So what we can see is that the spring has been pressed with the distance of the length of 2/5a. Then this is your maximum extension, x. Okay. So when you have a maximum extension, your V will be a 0. When you first release, your U is also 0. Okay. So from here, we will be using the conservations of energy to do it. So we have, you can see that from the diagram that we have, the GPE is gain. Then the KE will be lost. No KE. KE is a 0. Only EBE is lost. Okay, so we have the formula for the GPE is mgh. And the EBE is lambda over 2L. x2 square minus x1 square. Okay, so this is the h. So the h is actually 2/5a plus x. Okay, so we will write this as become 2/5a plus x. Your lambda is a 20 mg. Your original length is a. Your extension at the beginning. Extension at the beginning, that means at the beginning you press with this much of the length, which is 2/5a. Then at the end, your extension is only x squared. Okay, so this is what we are having. Then we can straight away cancel the mg. Then I will get a multiplied by 2/5a plus x is equal to the 10 of the 4/25a squared minus the x squared. So I just need to multiply it inside. I get 2/5a squared plus the ax is equals to the 20 over, or not 20, 8/5 a squared minus the 10x squared. So you can see that we will be having a quadratic equations. I just want to make my coefficient as an integer. So I multiply everyone by 5. I get 2a squared equal to plus the 5ax is equal to the 8a squared minus the 50x squared. Rearrange them. 50x squared plus the 5ax minus the 6a squared equal to 0. Okay, so we try to factorize it. Then you can see that you have a 20 not 20, sorry, 2a and 3a. Okay. Then therefore your x is equal to the negative 2a over 5, and the x is equal to the 3a over 5. For the negative value, it will be ignored, rejected. Okay, so therefore your answer, therefore your maximum extension is equal to the 3 over 10a. Done. This will be the answer for the question number 1. Okay, move on. Number 2. G, move along a horizontal straight line against a resistive force of a magnitude 2 mv cube Newton, where the v meter per second is the velocity of b at time t second. When t equal to 0, v equal to 1, we want to find the expressions of v in terms of t. So if you resolve the forces horizontally, you get the negative frictional force is equal to the ma. So the resistance force is actually negative mv cube equal to the ma. So you will get A is equal to the negative 2v cube. So we want the answer of V in terms of t. So we need to change our A become dv dt. Then you just need to bring it over here. To dt. So integrate this, you will get this as the integrate negative v power negative 3 dv equal to the 2t plus c. So you get a negative v power negative 2 over negative 2. Then you will get 1 over v square is equal to the 2t plus c. Then when t equal to 0, v equal to 1. That means 1 over 1 square is equal to the 0 plus c. So your c is a 1. Therefore, 1 over v square is equal to the 2t plus 1. There's a 2 here, sorry. I make a mistake. Okay, so this is a 2. So the c is a half. Okay, then you multiply everyone by 2. You get 1 over v square is equal to the 40 plus 1. Then your v square is equal to the 1 over the 40 plus 1. But we want v in terms of t. Okay, so your v will be positive negative 1 over square root of the 40 plus 1. So because of the t equal to 0, v equal to 1 is positive. Therefore, your v will be square root of 40 plus 1. That will be the answer for the question number 2a. Okay, so this one continue over here. Okay, so now we move on to the B. We want to find the displacement of B from the initial point when the t equal to 6. Okay, so over here, we need to integrate them. So your V is 1 over the square root of the 4t plus 1. I will make it as a 4t plus 1 power negative half. So I make it become the x dt equals to the 4t plus 1 power negative half. So that to integrate, okay, to integrate this graph, to integrate the functions over here, I will have x equal to integrate the 4t plus 1 power negative half dt. You are looking for the displacement from the initial point. Initial point means when the t is equal to 0. until 6. So you can straight away integrate like this. Then you can get this as a 40 plus 1 power half divided by half times 4 plus, no need to put plus a constant. We straight away replace the lower bound and the upper bound value here. Then we can get the answer. So over here, you will get this one as the half of the 25 power half minus the half of the 1 power half. So you get the x is a 2. That is a displacement. Okay, you can integrate it like this. Okay, done for the number 2b. Move on. We have a question number 3. Question number 3, we have a particle P projected with a speed u at an angle alpha above the horizontal from a point O on the horizontal plane and move freely under gravity. The horizontal and the vertical displacement of P from O at any subsequent time t are denoted by x and y respectively. We want to derive the equations of the trajectory motions over here. So we will start from the horizontal displacement, which is the x equal to the u cos alpha t. Then for the vertical displacement, your y is equal to the u sine alpha t minus a half g t squared. And over here, we make this t become x over the u cos alpha. Equation 1, I call this one equation 2. Just need to substitute equation 1 into 2. You will get y equal to the u sine alpha, x over the u cos alpha, minus a half g x square. So if you expand it, you can see that you have a u and u cancel. You have a x tangent alpha minus a gx square over the 2u square cos square alpha. But because of 1 over cos square alpha is actually a secant square alpha, so you can make it become this. So shown. This will be the answer for the question number 3a. Move on, we have a 3b. It is given that the u is equals to the 20 sub 2 meter per second at the particle P passes through the point x equal to the 64 and the y equal to 8. Find the possible value of tangent alpha. Okay, so given u equals to the 20 sub 2 at the point of 64 and 8. Okay, so from the equations just at part A, from A, we will have 8 equal to the 64 tangent alpha minus the g x square over the 2u square secant square alpha. Okay, so we just need to simplify them carefully. So you have 8 equal to the 64 tangent alpha, and this one, it will be 128 over the 5. Secant square alpha, I make it become 1 plus tangent square alpha. We want to make the tangent alpha in the quadratic form. Multiply every 1 by 5, divide every 1 by 8. Okay, because you can see that the numerator always a multiple of 8. Multiply 5, divide 8. You get this one as a 5, this one as a 40, this one as the 16. But that one side to become 0. So you get minus a 40 tangent alpha plus the 21 equal to 0. So we try to factorize it. You get a -7, you get a -3. Okay, so this is what we are having. Then your tangent alpha is equal to 7/4, and your tangent alpha is equal to the 3/4. So these are the two possible value of the tangent alpha. Okay, done for the question number 3B. Okay, move on. Question number 4. A diagram over here shows a hollow cone with the smooth inner surface. Is fixed with the vertex O downwards. The semi-vertical angle of the cone alpha were given as tangent alpha equal to the 4/3. A light inextensible strings has a particle A of mass m attached to the one end of a particle B of the mass m attached to the other end. The string passes through a small hole in the cone at O. Particle B hangs equilibrium below O. Particle A is on the inner surface of the cone at the height h above the level of cone of O, and move horizontal circles with a constant angular speed omega. Then find the omega in terms of g and h. So over here, we need to settle a few things first. We need to find the radius. Okay, so maybe we can draw a diagram. This is the h, this is the r, this is the alpha. So we are having that the r over h is equal to the tangent alpha, and they give you tangent alpha is 3/4. So r is equal to the 3/4h. And also they give you tangent alpha is 3/4. We can actually build a right angle triangle to have 3 here, 4 here, and 5 here by Pythagoras theorem. So these are the material I need to get ready before I solve the problem. Now, usually for a question like this, we will start from the one that is hanging vertically. That will be the easiest for us to get marks. So at B, if you resolve the forces vertically, you have the tension T is equal to the mg. Done. Then at A over here, maybe we can draw a diagram. You can see that the A is over here. Then this is the normal contact force R. This is the mg. And this is the theta, not theta, alpha. Which means that this is alpha. This is the tension, okay? Because the T over here is pulling up, then the T over here is pulling down, okay? So the tension go like this. Okay, so if we resolve the forces of A vertically, maybe we can go vertically first. So you have a R sine alpha is equals to the mg plus the T cos alpha. Then R sine alpha is 3/5. The T is over here, mg. Cos alpha is 4/5. Okay. So from here, you can join together. This one join together, it will be 9/5. So times 5/3. So R is equal to 3 mg. Okay. This one just never mind. I just leave it like this will do. R equal to 3 mg. Then if I resolve the forces horizontally, I get the R cos alpha plus the D sine alpha is equal to the centripetal force, mr omega square. So your R is 3 mg, your cos alpha is 4/5, your D is mg, your sine alpha is 3/5, What is your R? Just now, the R was found as 3 over 4H. Cancel the M. Join together. You get the 3 over 4H omega square is equal to the 15 over 5. 15 over 5G. 15 over 5 is a 3. So your omega is actually equal to the square root of 4G over H, or you can write it as a 2 square root of G over H. Done. This will be the answer for the question number 4. Move on. We have question number 5. Lamina ABCD is a uniform square lamina. The side is 6A. Point E and F are on the DC and AB respectively and are such that the DE equal to the FB equal to H. And we have a quadrilateral BCEF is removed from the square lamina. Show that the distance of the center of the mass from the resulting lamina AEFD from AD is these equations, is these expressions, and find the corresponding expression for the distance of the center of mass from AB. Okay, so we are looking for center of the mass. That means we are looking for the bar X and we're looking for the bar Y. So the bar X, we need to show the bar X look like this. Then after that, we only find the bar Y. Okay, so what we need to do is build the table. Before we build the table, I think I will take this into a coordinate system. I try to draw it out. So this is a origin. This point is a 6A, 0, 6A. This point is a, what is this point? This is a 6A minus H. So this is, oh, but this one is the given is H, so it's a H. 6A. Then over here, this is a 6A minus H and then 0. And this point will be the H and then 0. Okay, this is what we are having right now. So from here, with the table that I draw over here, we can try to draw a table, put in the informations that I have drawn just now. So we have a lamina. I break the diagram into a rectangle and a triangle. So we have the combined particle, combined object. So since it's the same material, we are using area will do. No need to use a mass. Area for rectangle is the base times height. So the base is H, the height is a 6A. So it will be 6AH. Then the triangle is half times base times height. So the base over here is actually 6A minus H minus a H. Okay, so you get a 6A minus a 2H. So the area will be the half times the base times the height. The height is a 6A. So if you go and multiply it, you will get this one as the 18A minus the 6H. So you have a AH, 18A square minus a 6AH. The total will be 18a squared. So the center of the mass from AD. And we also need to find the center of the mass from AB. So for rectangle, it's actually the middle point, the midpoint. So it's at here. So it will be half of the h. And it will be 3a. This one is simple. And as for the rectangle triangle over here, you just take these three, add together, divided by 3. So you have a h plus a 6a minus h divided by 3. So you have a 2a plus 1 over 3h. Same thing goes for the y. This will be 6a, 0 and 0. 6a plus 0 divided 3, you get a 2a. So this will be the bar x, this will be the bar y. We are looking for bar x and bar y. So now we are ready. Just take the moment about the AD. So you have a 6ah multiplied by half of the h plus the 18a squared minus the 6ah multiplied by 2a plus 1 over 3h is equal to the 18a squared bar x. So we can expand. We will have a 3ah squared plus the 36a cube, then plus the 6a squared h minus the 12a squared h minus the 2ah squared is equal to the 18a squared bar x. So your bar x will be equals to the 36a cube minus the 6a squared h and then plus the let me double check. Plus the ah squared divided by the 18a squared. You can see that the a can be cancelled. So if you cancel the a, then you can get h squared minus a 6ah plus the 36a squared over the 18a if you divide everyone by a. So therefore shown. Okay, that is correct for the bar x. Now we are looking for bar y. So for bar y, this one is the moment about. So you will have 6ah multiplied by 3a plus the 18a squared minus a 6ah multiplied by 2a is equal to the 18a squared bar y. So if you cancel the a, you get the bar y is equal to the 18ah plus the 36a squared minus a 12ah divided by the 18a. Simplify it, you will get this one as the 6ah 6ah then plus the 36a squared divided by 18a. All the a can be cancelled, and 6 and 36 is a multiple of 6. So we can actually simplify it, make it become 2a plus 1 over 3h. Done. This will be the answer for the bar y. Okay, so now we move on. They say that the lamina is then the lamina AFED suspended from a point D at the edge DA makes an angle theta with the vertical downward, with the downward vertical, and the tangent theta is a 7/15. Find the two possible values of A in terms of A, at two possible values of H in terms of A. Okay, so we can draw a diagram. This is the D. Let's say the center of the mass is over here. Okay, let's say I call it G. So if you hang vertically, this is the vertical. Okay, then this is the AD. It makes an angle theta with it. So we need to calculate. Just now we calculated that this is the bar X, this is the bar Y. So from here, we know that this is the vertical. So from here, the tangent theta is equals to the bar X divided by the 6A minus the bar Y. So this is 6A minus the bar Y. So tangent theta is given as 7/50. Bar X is given as the, maybe we don't put it first. We simplify first, make our job easier. So I have a 6A minus a bar Y is equal to the 15 bar X. Now we can expand, become 42A minus a 7 of the bar Y. Bar Y just now is a 2A plus 1/3H. Then this one is a 15 H square minus a 6AH plus the 36A square divided by the 18A. So we keep expanding. I get a 42A minus the 14A minus the 7/3H is equals to the 5/6. I get 5H square minus the 30AH plus the 180A square divided by the 6A. So I multiply everyone by 6A. Okay. So over here, if I multiply by 6A, so if I multiply by 6A, I get this one as the 2A multiplied by 6A. So this one is 8. And this one is 12. 258. Okay, what am I doing? These two can combine. These two can combine, then you will get this one as this one combined, you become 28A multiplied by 6A. (168A square). Okay, so this one will give you 168A square minus the 14AH equal to the 5H square minus the 30AH plus the 180A square. So you will have 5H square minus the 16AH, then plus the 12A square is equal to 0. Okay, you have something like that. Then you factorize it. We're having a quadratic equations over here. You factorize it. This will be a negative 6A. This will be a negative 2A. Then therefore you get the H is equal to 6/5A. and the h is equal to 2a. Okay, so both of the value can be accepted because it's still within the range that we can accept. So therefore, these are the two possible value of h. Okay, done. This will be the answer for the question number what? Number 5. Okay, this is the answer for number 5. Now we move on to the number 6. We have a diagram over here show two uniform smooth sphere A and B of equal radii have the masses of 5m and 4m respectively. Sphere A is moving with the speed u on the horizontal surface when it collides with the sphere B, which is at rest. Immediately before the collision, A directions of motions makes an angle theta in the line of center, and the coefficient of restitution between the spheres is E. They want us to show that the speed of B after the collision is 5/9u, multiply 1 plus E, multiply cos theta. So how to show it? Usually I will just write before and after. So before I give a diagram that this is the 5m, this is the u, this is the theta, then this is at rest, is a 4m. Then after you collide, this is the VB, then the VA, I still assume that the direction will be going downward as this, but this angle has changed to become the VA. This is the 5m. Okay, so we have before and after. Now we will consider the principle of conservation of linear momentum, PCLM. So we have the 5m u cos theta plus the 0 is equals to the 5m VA cos alpha, and then plus the 4m VB. Cancel the m, you get a 5 VA cos alpha plus the 4 VB is equals to the 5u cos theta. That is the equation number 1. And Newton experimental law, NEL, you have a E equal to the negative of the VA cos alpha minus the VB divided by the U cos theta minus a 0. So you will have the VA cos alpha minus the VB is equals to the negative EU cos theta. So we just need to make the VB is equals to the VA, sorry, I think we want to find VB, yeah. I make the VA cos alpha, the VB minus the EU cos theta. I call this on equation 2. 2 into 1. Then I get the 5 VA cos alpha VB minus EU cos theta is equal to plus the 4 VB is equal to the 5U cos theta. Expand simplify, you get a 9 VB minus a 5 EU cos theta is equal to the 5U cos theta. So your VB is equals to the 5/9 1 plus E U cos theta shown. That is the answer for the number 6A. Now we move on to the B. Okay, so we move on to the B. After the collisions, the KE of A is equal to the KE of B. And given that the tangent theta is equal to 2/3, find the value of E. So the tangent theta is 2/3. We make the right angle triangle over here. This is the 2, this is the 3. Pythagoras theorem say that this is a square root of 13. Okay, So we can direct from A. We get the VB is equal to the 5/9, 1 plus E U 3 sub 13. Then we can make it become 5, 3 sub 13, 1 plus E U. Okay. Now we need to find the so-called VA square. Okay. Yeah. So from the equation 2, we have a VA cos alpha is equals to, for these equations, we have a VB minus EU cos theta. So we have a VB minus a EU cos theta. So you get this as the U sub 13. We factorize the 3 out. Then we get a 5 plus 5E. Then minus a 9. Minus a 9E. So you will be having this as the 5 minus 4E. The 3 sub 13 U. That is the VA cos alpha. Now we want to find VA sin alpha. So at A, if I resolve the component horizontally, I have the VA sin alpha is equal to the U sin theta. Sin theta is actually 2 sub 13. 2 over sub 13 U. Okay. So your VA square, it will be equals to the VA cos alpha square plus the VA sin alpha square. That will be equals to the 5 minus 4E, 3 sub 13, square U square plus the 2 sub 13 square and then U square. Okay, so this one a bit troublesome. We have to expand them carefully. So over here, I think I will just leave like this at the moment, make it become 5 minus 4E square divided by 117 plus the 4 over 13 square. Just leave it like this at the moment. Okay. Then given KE at A is equals to the KE at B after the collisions. So that means the half of the 5m of the VA square is equal to the half of the 4m of the VB square. So cancel the m, cancel the half, you get a 5 VA square as what I have written just now. Okay, is equals to the 4 of the VB square. VB square was 5 over the 3 sub 3. So we have a 5 over the 3 sub 13 of 1 plus EU squared. Yes. So the U square can be cancelled. Cancel the U square. So you get this one as the 25 times 4, 100, 1 plus E square divided by 117. This one, it will be 5 of 5 minus 4 E square divided by the 117. This one will be 20 over 13. Okay, so we just need to cancel it. Multiply everyone by 117. You get a 5. 25 minus the 40E plus the 16E square. Then plus the 180 is equals to the 100 E square plus 200 E plus 100. So you will get 80 E square minus a 200 E. And then 125. 305 is equal to the 100 E square plus the 200 E plus the 100. Simplify it, you will get, okay, need more space. Sorry for that. Just hold on for a while. So if you continue to simplify the equations over here, you will get this one as a 20 E square plus the 400 E minus a 205 equal to 0. So if you divide everyone by 5, you get these equations. Then you factorize it, you will get 2E plus a 41, 2E minus 1. Then you get the answer E is equal to the negative 41 over 2, and E is equal to half. This is rejected. Therefore, your E is a half. Just like that. Done. So this will be the answer for the question number 6. Moving on, we have a question number 7. We have a particle P of mass M is attached to the end of a line index sensible string of the length A. The other end of the string is attached to a fixed point O. The particle moves in a complete vertical circle with the center O with the string top. When the string makes an angle theta with a downward vertical O, the speed of P is square root of 4 ag. The ratios of the greatest and the least tension in the string during the motion is 11 to 1. Find the value of cos theta. Okay, so we are having a vertical motion of circular motions over here. We have a string that makes an angle theta with a downward vertical. So this is the tension. The U over here is a square root 4ag, but the question didn't mention is going up or going down. Okay, because we are looking for the greatest tension and the lowest tension and the least tension. So we know that the greatest tension will be at here. Okay, so this tension is we call it, I call this point A lah. Okay, and I call this point, okay, I call it that the highest point is at the point B. And this tension is a TB. Okay, and over here, I call this particular B. Okay, so we want to consider going up here and want to consider going down here. We have two situations to consider. Okay, so we consider the case of B to A going down. Okay, consider the case of B to A. So our conservations of energy says that the GPE loss equal to the KE gain. The speed over here, it will be the VA. The speed over here is a VB. So you will have mgh is equals to the half m of the VA square minus the U square. So you have the VA square is equal to the U square plus 2GH. The U square is given as 4AG. And the H is given as the A minus the A cos theta. Simplify them, you will get 6AG minus the 2AG cos theta. That is your VA square. Then at A, when you resolve the tension vertically up, you are having the maximum, this one is a maximum tension, minus the mg is equal to the centripetal force. So you will have dA is equal to the m over A, 6AG minus the 2AG cos theta plus the mg. So at the end, you get 7mg minus the 2mg cos theta. That is your dA. Then now we consider the situations that the P to B. Okay, so we consider the situation P to B. Conservations of energy. We have the GPE gain that will give you the KE loss. It will be the mgh is equal to the half m of the U square minus the VB square. So you get the VB square is actually U square minus the 2GH. And your U is actually 4AG. And your H is A plus A cos theta. Simplify them, you get 2AG minus a 2AG cos theta. That is your VB square. So at B, if you resolve the forces towards the center, you will get the dB plus the mg is equal to the mvb square over A. This will give you the minimum force, the minimum tension. So the dB will be equal to the m over A, 2ag minus the 2ag cos theta minus the mg. Simplify it, you will get the dB is equals to the mg minus the 2mg cos theta. Okay, this is what we have. Given that the dA to the ratio of dA to the dB is equals to the 11 to 1. That means the dA divided by dB will get 11 to 1. That means the TA is equal to the 11 dB. So the dA just now is a 7 mg minus the 2 mg cos theta. The dB is a 11 mg minus a 22 mg cos theta. All the mg can be cancelled. So you get this as the 20 cos theta is equals to the 4. So your cos theta is equal to the 4 over 20 and is equal to 1 over 5. Done. Okay, that is the answer for the question number 7. And this will be the last question for this paper. I will stop the video here. I'll see you next time. Bye-bye.